mean?
AB plus AB.
AB plus AB, very good. So 2 times AB is just multiplication, okay? Which means I can rewrite that as AB and AB. That's what I need to think of. Because looking at the problem, they are talking about segments. Well, in this case here, when we're looking at segments, we're talking about segments probably adding together. Just like we always do, we always start each problem with the given. Given in this case is this. Well, there's no real progression that I can do out of this. There's nothing that says, hey, if given multiplication, what do? Well, you have to remember that in a previous problem, take something, paper out and write something down. Don't just stare at the board. It's middle of October, you don't have paper.
I'm sorry, I forgot my locker. I usually bring it.
In this case here, there's no progression, there's no definition, there's nothing out of it. But there's something that's written in there, the 2 times AB. Yes, sir? No. Reflexes is just saying that you are yourself. The 2 times AB means, like you just said, AB plus AB. That's all I can do here. That's all I can do. And all I did from this to that is just use the pure definition of multiplication. On your reason bank, on that first chart that I gave you guys, at the bottom of that, we did an example of what multiplication was. Multiplication was repeated addition. So if you have things that are multiplied together, you just break them apart is 2 separate addition problems. Because we have things that are called segment addition. We have things that are called angle addition. We have nothing that's called angle multiplication or segment multiplication. So we have to look at it in those terms. Yes, sir?
So you can't do the top, so you gotta bring it down, and you just, like you said,
Right. That's just the pure definition of multiplication, is repeated addition. Look at your diagram. Does your diagram say AB plus AB is BC? Or AB plus AB plus BC is AD? No, it says AB plus BC plus CD is AD. According to the diagram,
What?
3 segments add up to equal the larger. When you're adding segments, what are you doing? Very good. Segment addition. That's it. Sometimes segments might be more than 2. That's all. Do I have 2 things that are the same equal to 2 different things? Yes, sir. Yeah. Are those 2 the same? Yeah. Do they equal 2 different things? So that means the different things have to equal each other. Very good. And when you put something in for something else, you are using substitution. That's all it is, guys. Looking at that equation, are there things that are the same on both sides? Yes. How do you get rid of them? Very good. Those are the same on both sides of the equal. To move them, to get rid of them, I just subtract them. So if you subtract the same thing from both sides of an equal sign, you're using sub t prop equal. Am I done? No. This one wanted me to show that those 2 were congruent. That's right, they're congruent. like I said, We've done this proof before. We've done this proof before, but I think we started it where you had to show, I think there was, AB was equal to BC, and you just had to do a substitution that way to get to multiplication. You just kind of go in the other direction. Guys, I don't know how to make this more blatantly clear here. Do you only know a couple of different things? Segment addition, angle addition. You know a little bit about right angles. For the most part, it is rewriting segments in terms of smaller segments, setting them equal to each other, and probably subtracting. Sometimes you're creating larger segments by adding things to both sides, which therefore make other things equal to each other. Okay, it's the same thing, but more often than not. Sir? Okay.
No, I need to see.
Oh, I got you. Do this. All right. Let's try another one. Without even looking at the picture, and you say that B is between A and B. But I don't even want to bother looking at this picture because I don't really need to right now at all. If I know that B is somewhere between A and D, what would A and D be on a segment? Beginning, the end, the endpoints. So that just means that A and D are endpoints. If B is between them, does it matter where B is placed? What's created? Two segments. Right? That's what that means. Same idea. A and D, C is somewhere between them, right? What's created? Do I have two things that are equal to the same thing?
Yes.
That means these things have to be equal. That's all that is. That's all that is. The idea here by saying something is between allows you to do, it tells you they're collinear. It allows you to use segment addition. That's what that means. Segment addition, I think on the reason sheet, if I'm not mistaken, actually says collinear points, I believe.
Yeah.
Yeah. Or does it? Wait. Yes, if B is between A and C, then AB plus equals AC. It's on the very top of this reason bank. It's the exact same thing that's given here with different letters. It told you exactly what you would use. Okay? It tells you exactly what to use. It's going back and forth and looking at parts to know where to go for, where to look for information. Okay? Start with the givens. Using the definition of segment addition, or just using segment addition, that's what that means. Why, hello! How are you?
I'm good, how are you?
I'm fantastic. Hey, thanks. That is right and straightforward the example of segment addition. And I do the exact same thing with the next given. Just like I showed off to the side here, just by looking at it, what does it mean? By thinking about the picture of it. Remember the first 10 questions I gave you last Friday that maybe only half of you guys did? Where it said, if given this, what do you say and why? Well, that's what this stuff is, guys. And it all boils back down to you guys not doing your homework. And there you go, segment addition. Do we have two things that equal each other? Therefore, those parts equal. Well, actually, I think I said that backwards. AD and AD are the same thing. They're the same segment. They're written up as equaling different parts. Those different parts, therefore, are equal. And the reason I could put in something for something else is substitution. So if I look back at this proof, the only thing I had to come up with on my own was the very last step. 80% of the proof was done because of the progression sheets or your reason banks. 80% was complete from looking at your sheet of paper. So it's an idea that you have to be resourceful. You may not know how to do that last step and say, hey, Mr. Murphy, I'm not exactly sure what substitution looks like. That's a great question to go over with you. But if you can't just read what to do on the sheet of paper that's already there, that's a bigger issue, okay? So remember, these sheets, these progression sheets, these reason banks, the information is there for you to resource it. It gets you over half the way done with the proofs. In this one, 80%. That's a B, okay? If you start thinking through it, resourcefulness, guys. You have to be resourceful with this stuff. The very first progression we did was midpoint. Make sure you have your sheet out, follow it. This one should have been the easiest of them all. When you have a midpoint on a segment, that segment is cut into two equal congruent segments. So according to our progression sheet, it said B is the if you have if given midpoint, you would state the two congruent or equal segments. In our generic proof that we put in our progression sheets in our squares, we said segment equal segment, or I think we might have said segment congruent segment.
Yeah.
Does it matter which one you use? Sometimes you'll use congruent, sometimes you use equals. Which one do you think I would use here? Equal, why? Because there's no congruent, right. And even still, see how there's an addition sign there? Can you add, subtract, multiply, divide any problems that deal with incongruency? No, those all have to be in equality. So we look at our progression sheet. What does your progression sheet say about midpoint? Okay. Now, we all have that on there. Make sure you have that on there correctly. B is a midpoint. So that means that AB. Well, we're getting to that in a second here. I'm going to leave it as equals because I know that I'm going to have to show something with addition here in a minute. So it's okay to write midpoint as segment equal segment or segment congruent segment because of the way that the rest of the proof is going to work. I can do either one. That works the same for angle bisector, segment bisector as well. You can write either they're congruent or that they're going to be equal. Either one is fine. It's just you have to sometimes look ahead as to what you're gonna have to do later, okay? That's what we have to worry about. So now, what, AB equals BC because we just used, very good. Did you have a question though, Mr. Dillon?
No.
Very good. Anyone help you?
All right.
So, we now have AB equals BC. That's all I can get out of that midpoint. What I need to do now is go to my diagram and mark it, AB and BC. I put the tick marks in. I now have to take a guess as to what I need to figure out. So I look ahead to what I have to prove. The proof wants me to say AB and CD is BD. So it wants me to say that AB and CD is this whole segment here. Well, BD is a larger segment. Do you agree? BD is made up of what two smaller segments? BC and okay. So let's do this. Let's say that BC plus CD. Why can I say that two smaller segments add up to equal or bigger? Segment addition. Yeah. Now, I've already said that BC equals AB, which means everywhere I see a BC, what can I put? Why? Very good. And you're done. This one's a little bit different. This one, your progression sheets are going to get you halfway there. You actually had to look at the diagram then to decide what to do next with in terms of what they want you to prove. But as you can see, it's kind of the same process again. We have two segments equal to each other. This was a segment addition because we know that a bigger segment is made up of two smaller. And all we do is just flip-flop some letters around to get us to rewrite. Okay? That's what we're looking at doing. That's about the complexity of what you need to be able to do as a vector. I mean, things get a little bit trickier later, but for right now, they shouldn't be. They should be very, very systematic. Do this, then this, then this, and so on. Okay? We all right on this one, or are you guys still ready?
Wow.
And then the answer. Last one deals with the angles. Excuse me. Last one deals with the angles. We have angle AEC is congruent to angle DEB, and we want to prove that angle AEB is congruent to angle DEC. So when we look at our diagrams here, what we need to first of all look at is what are we being given? Now yesterday we did a couple of different examples that dealt with having to add in the middle wedge with both a segment and as well with an angle. But if you look at this case, we're given the big angles going left and right, where that middle wedge is an overlap with both of them. When you draw that, you should see that as you put your tick marks through. I have this and this. They want me to show that the two smaller edge angles are going to be equal to each other, or congruent. They want this to happen. Well, in order to make that happen, what do you have to subtract out? What do they have in common? They got that middle wedge in common, that BEC. Everybody see that? If I take this middle wedge out, all I would be left with are these two outer angles. So what we are having to do here is we're going to have to set it up in terms of an angle addition. Two smaller angles equal the larger. We know the largers are congruent to one another. So we would say the two smaller parts have to be equal to each other. And then we can back out what they have in common, and lo and behold, you'll be left with what's left over. That's all that is. If you think about it in terms of numbers again. Let's see. 12 equals 12. You agree? Do you agree with that?
Yeah.
What do they have in common? Well, either one. If I want to say that, we'll say the 8's in the middle wedge part. If I draw this out on an, well, see if I can do it this way, where it was overlapped through. These are the same, right?
Yeah.
If I get rid of it, do I still have a true statement?
Yes.
That's what you're looking at doing. Okay?
See, that makes sense.
What?
Numbers.
They're just letters. They're not trying to mess you up. As much as you guys don't believe me, we're really not trying to screw you up with this. We're trying to show you that if things have a common overlap, paper is 8.5 by 11, right? So if I say paper if I say the piece of paper is wedged over like this as a segment, where they both have a 2 on the outer edges and a 9 in the middle. If I get rid of the 9 in the middle, what would I be left with? Does 2 equal 2? Yeah. That's what that is. You're rewriting the 2 segments themselves as 2 parts, and then you back out the middle, and you're still left with the same thing. That's what that looks like, except that it's turning as an angle, okay? It's the same basic principle. So the idea that, is there an overlap, am I adding something in? This case, I'm starting with the overlap. I gotta get rid of it. But in order to get rid of it, we have to put things in terms of addition. I'm starting in congruency, which means I have to put it to equal. I gotta make it equal first. So first thing I do is do a given. I don't have to, and that came up first hour as well. The question she was asking, guys, was, do I have to say that BEC equals BEC, angle BEC equals angle BEC? That. Remember how yesterday when we had that wedge in the middle, we were adding it in? We had to define it? You only have to define it if you're adding it in. If you have to subtract it out, it's already there. Does that make sense? Because I can already say that since we're starting with the larger angle, if I rewrite that larger angle in terms of the 2 smaller, I can say this. Angle AEC is made up of the 2 smaller angles, AEB, and angle BEC. I don't have to define it. If I do define it, is that wrong? No. It's just an extra step that you didn't have to have. A lot of times with proofs, if you throw in a step that you don't need to have, it's not a big deal. You might realize later on that, oh yeah, I didn't need to do that. It's no big deal. It happens. Okay. But remember, the only time you have to add something in is if you're going to add it to both sides of an equal sign. If you're going to have to subtract it out, you don't need to worry about it. Okay? Does that make sense? You're shaking your head no.
Me?
No. What don't you get? What is it? You want to put that on the sheet, on the square? When to add and when to subtract it, if you have to define it? Go ahead. Seriously. If you want to put that in a square about when do I have to do a reflexive, if you want to remember, it's easy to remember this way. When you use reflexive, if you have to add in a common overlap? Just like put that in a square as a reminder. Okay? When do you have to use reflexive? When you have to add in a common overlap. Is that fair? Is that a decent example of it? I don't care if you have it on that sheet, that's fine. That helps. Okay, it's fine by me. So here, I just said that one angle is made up of two smaller ones. That's what? English, good. So I did that with one of the angles. What do you think I should do with the other big angle? The same thing. I'm going to say that big angle DEB, good old Deb, bless you. Deb is, what is it, DEC and BEC. And again, it's an angle addition. So you started with two bigger angles. You knew those two bigger angles were equal to each other. You wrote down that the two bigger angles were made up of two smaller angles, which means that the two sets of smaller angles have to be equal to each other. And this is the one downfall about angles. There's so many letters. A lot of times there's a lot of letters and symbols. You gotta make sure you use the symbol, make sure you use 3 letters for your angles also. So I know since these two guys are equal here, those two have to be equal.
How are they equal to not the same?
What's that?
Are they equal to not the same?
What do you mean?
Like usually it's like the same.
Well, they are the same. That's why they're exactly. They are the same because they are equal. Because we know that since these two big angles are made up of the two smaller, if I do this in terms of, forget the lettering for 1 second. If we know that the big angle here is made up of angles 1 and 2, and the big angle here is made up of angles 2 and 3, that means that 1 plus 2 is equal to 2 plus 3. What do they have in common? So what do you know about 1 and 3?
1 plus 2 is 3.
No. Again, big angle is made up of angle 1 plus angle 2. Other big angle is made up of angle 2 and angle 3. The two big angles are equal to each other, which means that angle 1 plus angle 2 has to equal angle 2 plus angle 3. What do they have in common? What does this statement have in common on both sides? 2's. So what do then what do you get? 1 equals 3. Just like that.
I said that.
No, you didn't. You said 2.
No, I said 1 equals 3.
Oh, I thought you said 2.
No, he did, he said 1 plus 2 equals 3.
No, that was before that.
Well, don't do that.
I didn't say it.
No, we're almost done.
No, like this.
Yeah, this one's a pain. A lot of times when you wind up with like 4 angles to write out, it just takes up space, and sometimes it's just kind of a pain to write it out. It's unfortunate. The ones that look the most messy when you're doing proofs are ones that deal with angles because you use so many letters a lot of times. Also, the ones that tend to be the longest style proofs are the ones that you deal with perpendicular, because there's so many things to say about perpendicular. You go through one step and you can say 5 things. So that's why a lot of times if you see a perpendicular proof, there's a lot coming up. Let's see here. So we got these two that equal to each other. Did I write that? BEC? Oh, I wrote CE by mistake. So this was a substitution, putting in one for the other. What do we have that's the same on both sides now? BEC. How do I get rid of them? So I'm left with, oops. And there's your sub T. And what's left? I think this one said prove congruent. So just make it congruent. Bless you. Somebody asked earlier today, is your last step always going to be definition congruency? No. It just depends upon the proof. Sometimes it is, sometimes it's not. Okay? Sir. Yeah, I circled these two because I knew earlier we said that they were the same. Since those two are the same, what they're made up of has to be the same. Like I said, 12 equals 12. Well, that means that the 4 plus 8 that makes up the 12 has to equal the 4 plus 8 that makes up the other 12. Correct. Yep, that's the idea. And that's why we mark up the diagrams to bounce things back and forth to make it work. Okay? Is that helping-ish? Ma'am?
On the bottom, you put AED.
Oh, thank you. That's the other thing. When you start going through these letters, you easily mix a letter up. Now, what if you did all this if you accidentally wrote AED? Yeah.
You're not going to mark us off because you didn't
The fact that she says it and it goes, she smirks it. What? Yeah, I know you guys got fridge stuff here. Let me pass this thing through. I want to talk about a couple more for tonight, and then I'll give you some post-it notes. I think fridge was what, 80% would have been, what, 24?
Yeah.
Honestly, I'm gonna go home and study all this. I literally forgot. I don't even know.
I was gonna watch my video.
Like, I would really get some of the movies that are already been there. I should be happy
I
about
don't get what they do.
If I didn't get enough of those back around, you guys let me know. I got more of them, okay? Who needs it? 24 up. Oh, right here.
I got it.
She did it. All right, as these are coming around, 24 and up goes fridge, okay? Has everybody gotten one yet? Yeah. Thank you. I got one now. You're the best.
I didn't get one.
So,
We didn't get one.
you guys need more coming up? Are they coming up still? Hulu, you guys got more coming up? Isaiah, do you have more of these coming up? Really? You should have more. On the...
No, we don't.
So on this sheet here that I gave you guys, what I'd like you guys to do are the first 6.
Let's bring out more. Here you go, guys.
Okay. What I'd like you to do, come on guys, I don't have much time here. I want to show you a couple of tricks. So the segment and angle proof sheet, I want you to go 1 through 6. Now, real fast, numbers 1 and 3 are basically the same.
What does it mean?
Numbers 2 and 4 are also just about the same. Okay? They set up very similarly. The difference between 2 and 4 is that you'll notice that in number 2, you start with equal, you end in equal. In 4, you start in congruent, end in congruent, which basically means you're going to have 2 more steps, switching to equality and then coming out of equality to the congruent. On number 5, it talks about complementary. What do you know about complementary angles? Two angles that add up to equal 90. So at number 5, you're going to want to do a complementary progression where you're going to have angle 1 plus angle 2 equals 90. The next given, you'll notice that it says angle 1 is congruent to angle 3. But we just wrote something about equals. What do you think you should do with that?
Change it.
Change it. What do you think you should do about the next given where it says 2 is congruent to 4? Change it. So you're going to have a little bit of switches in number 5. Number 6 is a little bit different. Number 6 deals with vertical angles. Number 6 deals with vertical angles. And if you look at vertical angles on your progression sheet, what do you know about vertical angles? Is that their what? Who said it? You said it. Somebody said it. They're no fun? I thought you said they're congruent. Oh. Well, vertical angles, on your progression sheet, you should have something that's highlighted out as look for vertical angles. Vertical angles were that diagram that we drew that looked like this. When you see something like that in a diagram where you have vertical angles, like for example, 5 and 6, 5 and 6 would be considered vertical angles. So in a proof, I could say angle 5 is congruent to angle 6 because vertical angles are congruent. That definition of vertical angles on your progression sheet says vertical angles congruent. That's all you'd have to write. That's what you'd be able to use from that diagram. Okay? The rest of them get a little long-winded. The linear pair stuff, and then the very back one with the perpendicular. The number 10, we started to do that during first hour, and it was almost 14 steps. Because of the two different givens of perpendicular, right there, there's 5 steps each. There's a lot in that. It's not that it's difficult, it's right off the progression sheet. So it's just a lot of writing, okay? So get through those first 6, we'll go from there and see how we do, okay?